Hey, we are exchange student group and now let's show our presentation of scheduling. I'm in year 2 and the first part and second part is my part. First is scheduling algorithms for single processor systems. And first is first come first served algorithm. Um, its feature its tasks are scheduled in arrival order, and its advantage is simple and fair, but long tasks block short ones. And then is SJF. Its feature is short tasks are priority, but and the advantage is minimize waiting time. Disadvantage is long tasks may starve. And then is priority scheduling. Its feature is high priority tasks run first, and it handles important tasks promptly, but the disadvantage is long priority tasks may be ignored. And then it's round robin. It features that each task gets a time slice in turn. Um, it's fair, ideal for multitasking, but short time slices increase overhead. And then is MLFQ. Its feature is priorities adjust dynamically. It's flexible for mixed tasks, but it's complex to implement. And then is a comparison table. In the table, we can see FCFS is simple but can be inefficient. SJF has low waiting time but may be unfair, and the priority ensures critical tasks are completed but risk starvation. And RR is fair but requires careful time slice turning, and the MLFQ is powerful but complex, suitable for mixed task systems. And I'll use example to show how they work. First, in FCFS, processes are executed in the order of their arrival. If three processes P1, P2, and P3 arrive in order with burst time of 4, 3, and 1, FCFS will execute them sequentially. Is P1 is bigger than is first, and then is P2, and then is P3. And this method is simple but may lead to longer waiting time for some processes. And then is SJF. It processes with the shortest burst time first. Using the same example, if P3 has a burst time of 1, it will execute before P2 and P1, and so the order becomes P3 and P2 and P1, and this algorithm minimizes turnaround time, but it can cause delays for longer processes. And then it's priority scheduling. In this scheduling, processes are executed based on priority. For instance, if P3 has the highest priority, it executes first and followed by P1 and then P2. So the order is P3, P1, P2. And this approach ensures high priority tasks are completed first, but may stop lower priority tasks. And then is RR, round robin, assigns each process a fixed time slice. And if P1, P2, P3 have burst times for 4, 3, and 1, and the time slice is 2, and the execution order is P1, P2, P3. and then it's P1, P2. So this method ensures fairness but can increase turnaround time for short tasks. And then it's MLFQ. It divides process into multiple priority levels. For example, P1 starts in a high priority queue, and P2 in the medium, and P3 in low. P1 is executed first, followed by P2, and finally P3. This approach balances priority and fairness, but can be complex to implement. And then is second part, introduction to scheduling and types of scheduling. First is define scheduling and its importance. Above all, its goal is to optimize system performance, enhance resource utilization, and ensure tasks are completed according to their priority. And then is explain why scheduling is needed and the goals of a scheduler. Its goals of schedule include maximizing throughput, minimizing response time, fairly distributing resources, avoiding resource conflicts, and then introduce different types of scheduling. The first is long-term scheduling, and then medium-term scheduling, and the short-term scheduling. And then is describe the differences between types. Long-term scheduling focuses on long-term resource planning with a larger time scale and slower decision making. And medium-term scheduling optimizes performance by dynamically adjusting memory demands with a moderate time scale. And the short-term scheduling requires quick decisions, often based on process priority and CPU requirements. Then is impact of scheduling algorithms on system performance. Scheduling algorithms directly affect system performance, and there are some examples. Choosing the right algorithm can significantly improve system response time, throughput, and the CPU utilization. And that's all. Thank you.
Okay, my name is Pen Wu. In my part, I will introduce scheduling in multiprocessor and multi-core systems and the real-time systems. So here you can see the type of the multiprocessor. So first one is about loosely coupled and distributed multiprocessor or cluster. It consists of a collection of relatively autonomous systems, each process having its own memory and the I/O channel. The second one is functionally specialized processor, and the third one is tightly coupled multiprocessor. And about the environment of the multiprocessors, the important thing is about the different degree of synchronization. Granularity is the frequency at which processors synchronize across the system. It means how frequently they share data and perform coordinated execution. Here you can see it was separated by 5 parts. The first one is fine, next one is medium cores, very cores, and the last one is independent. Okay, so about the problems when we using multiprocessors to do something, maybe it's here you can see the design issues. The first one is the assignment of the processors. The second one is the use of multi-programming on the individual processors. And the last one is the actual dispatching of the process. The solution depends on the degree of granularity of the application and on the number of processors available. Here, I have 2 questions about it. Should the processors stay statically assigned to the processor or dynamically to the processor? Or if there are enough processors, it's necessary to design single processing multi-programming? Maybe not, right? And here you can see two allocation methods. First one is static, and next one is dynamic. Static it means task will run only on specific processes throughout the lifetime, and the other processor will run the other tasks. And about the dynamic, it means all process will go into the global queens, and then the process may be executed on different processes at different times. And here you can see two methods about assigning processor to processor. The first one is master state, and the next one is here. So here you can see this function is means operating system always run the particular processor. The other processor may only execute the user program. And about here, it means everything can execute on any processor, and each processor does self-scheduling from the pool available processor. But both then will create some problems, like disadvantage and the potential problems. About the second question, the use of multiprogramming on individual processor. The answer is when there are many processor, it's unimportant that each process as busy as possible, and the program will with multi-series will run poorly because they will wait unless all series can run all at once. About here, the third design issue, the actual dispatching of the process. Here you can see four methods of process scheduling. The first one is load scheduling, second one gun scheduling, and third one is dedicated process assignment. The last one is dynamic scheduling. Now I'm going to introduce gun scheduling. What about this? When we use this scheduling, we will think about a condition. It is granularity between the fine and the medium. The advantage is if processor in group will related or coordinated in some fashion, synchronization blocking may be reduced, thus process switch may be necessary and the performance will increase. A single scheduling decision affects the number of process and process at one time, reducing scheduling overhead. And here, the last part about cache affinity is very important. Here you can see I give you a example, and here you can see a queen A, B, C, D, E, and then you can see CPU 0 will execute A, and 1 will execute B, and CPU 2 will execute C, and CPU 3 will execute D. And then CPU 0 will continue execute some process in the queen. But the thing is, you can see in the CPU 0, you can see all of processes are different, right? So maybe process A need to switch E, D, C, B. All of these process need to switch. And here you can see the next chart, CPU 0. Here you can see A, E, A. In CPU 0, you can see process A execute in the CPU 0 at 1, 2, 3, 4, 4 times. It's very useful, and it can reduce cache invalidation and maintains cache locality. So this means cache affinity. Okay, next part about scheduling in real-time system. What do you mean about a real-time system? It means system that have temporal predictability must be provided. It's you can see 4 types. The first 2 is hard real-time tasks and the soft real-time task. And the last 2 is the periodic task and the periodic task. Okay, I'm going to introduce features about real-time scheduling system. It's determinism. It's an operating system indeterministic or to extend that performance operating at fixed predetermined times or within predetermined times interval. And how to measure it is the maximum delay from the arrival of the high priority device interrupt to when serving begins. And here you can see the difference between the hard real time and soft real time. Hard real time system focus on granted the deadline adherence, and the soft real time aims for best efforts performance. And about this process scheduling in real time system, it is rate monotonic scheduling. It's very useful. You can see, I give you example. Here you can see the task one. It's used 100 seconds, and the task two 150 seconds, and task three is used 315 seconds, and the period it means it will with the shortest period. The the high priority task is that one with the shortest period. Yes, and about EDF, the closer the task deadline, the higher its priority. The strategy that dynamically assigns priority based on the task deadline. And how priority supports real-time requirements. Here you can see three parts. The first one, priority assignment tech, RMS, EDF. There are schedulings, right? And pre preemptions, yes. And here you can see priority based on scheduling allows preemption, and the last one, avoidance of priority inversion. Okay, about the last part handles handles about a periodic task. About this part, I use a example from the textbook. You can see it show the three scheduling process scheduling. Earliest deadline with unforced idle times, and the FCFS. Here you can see if we use earliest deadline, it's the process B will missed. But if we use earliest deadline with unforced idle terms, it's not missed. Process B not missed. So we need to consider some conditions to choose different scheduling when we handle periodic tasks. Yes, this is my part. Thank you.